This video is for neutralizing solutions that are acidic. So if you are told in the lab procedure that you need to neutralize your waste at the end of the lab, that means we need to get the pH to a value of 6, 7, 8, or 9. So to test the pH, I'm going to use my pH paper, which comes from a tube like this, that I have taken the strips out and torn them in half or into thirds. And then I'm just going to take 1 drop of the solution from my glass stir rod and add it to the paper to see what the pH is by matching it to the color on the tube. So my pH is a pH of 1 right now, which is not one of the acceptable values. It must be 6, 7, 8, or 9. So this solution is too acidic. The pH is too small. It's below 6. So there are 2 different ways that you can neutralize this depending on depending on the chemicals you're given. You could be given some base solution like sodium hydroxide to neutralize, and if you're doing that, it works exactly the same way as it does for neutralizing the basic solutions in the other video. What I want to demonstrate is how we will neutralize it if you're given sodium bicarbonate solid, which sodium bicarbonate is baking soda. So I'm not going to lie, the baking soda that we use to neutralize this is actually pool neutralizer that we buy from Lowe's or Home Depot, because when we're using it to neutralize, it really doesn't matter its purity. So what I'm going to do is go ahead and open the container of the sodium bicarbonate that I was given and grab a scupula, and I'm going to stir with my glass stir rod, and I'm going to add some of this sodium bicarbonate to it. This is what we're going to see. What we're doing is this reaction. The bicarbonate polyatomic ion becomes carbon dioxide. That's one of its products. It becomes carbon dioxide in water. So when we do this, we're going to see bubbles. Okay. So I'm just going to keep adding this, and I can periodically check the pH. But I also know that, I'm telling you, that if you're still making a lot of bubbles, your solution is not neutralized yet, because there's still a lot of acid that's reacting with the sodium bicarbonate. So you don't want to have your beaker too full, because if it's too full and then it makes these bubbles, it's going to boil over. And while that might look super cool, you're going to have to clean that up. So I'm just going to add this until I see the bubbles slowing down a little bit. We could also add a drop of the phenolphthalein indicator, which will change pink when it's close to the time. I just like watching the bubbles, although I guess pink bubbles would be fun as well. I'm gonna keep. Now, if your solution, when we had originally tested it with the pH paper, was a pH of 6, 7, 8, or 9, we would not need to do this. We could just dump it directly down the drain. All right, I'm going to get a strip of pH paper. Oop, I got that dirty. And test the pH value, and it's still acidic. It's still very red, which when I compare that, it's acidic. So I'm going to add a bunch of baking soda here. It's still definitely bubbling. You can see it's getting pretty high. That's why you don't want to fill up your beaker too high, or you need to add much slower than I'm doing. Okay, I'm going to stir this up real good, and I want to check the pH value again. It's still acidic, it's still very red, so I'm going to keep pouring and pouring. Well, to me, it seems to be slowing a little. I'm going to stir it really good here. And I just test the pH, and it's now kind of a yellow color, yellowy orange color, which to me kind of is between the pH value of 6 and 7, which means this is ready to be dumped down the drain, and I'm all finished neutralizing. When we're using the sodium bicarbonate, it's very, very difficult to go past the past the 9 value to where it becomes too basic. But if that were to happen, where you kept adding the baking soda and the pH got to 10, then we would need to turn around and add more acid to get the pH to a value of 6, 7, 8, or 9. Just be careful not to let this bubble up over and make a mess, and just periodically check on your solution.